All right, lesson 16, Algebra 1. We are in Unit 6, graphing from the vertex form. The vertex form was introduced last lesson. We're just extending on it a little bit now. So, number 1, which form to use? Expressions in different forms can be used to define the same function. Here are 3 ways to define function f. We have standard form, which I've said is ax squared plus bx plus c. Factored form, which is 2 linear expressions in parentheses, 2 binomials multiplied together that we either FOIL or set up in that graphical order, there we go, when we multiply them like this to get sort of area. And then vertex form, which is very useful because it represents the vertex where things start. So, which form would you use if you want to find the following features of graph F? Be prepared to explain your reasoning. Number 1, if we wanted to find the x-intercepts, I would say factored form is the easiest because the x-intercepts are right there for us. It would be 3, 0, and 1, 0. 2, if we were looking for the vertex, well, amazingly enough, the vertex form is the easiest to use. For instance, here, the vertex is 2, -1. I can pick that out without doing any real math. And then 3, the y-intercept. Standard form is the easiest for the y-intercept because it's the constant. It's the c term. It's just 3. So 0, 3 is the y-intercept. Granted, I can pick that out pretty easily from the factored form also. If I multiplied those two, I get a positive 3. That'd be the last term of the binomial, and the last term of the binomial, I get a positive 3, which is the constant, which is the y-intercept. So that one works well, but cool. All right. So let's practice. Here are 2 equations that define quadratic functions, p of x and q of x. The graph of p passes through 0, -6, and 4, 10 as shown on the coordinate plane. Find the coordinates of another point on the graph of p and explain or show your reasoning. Then use points to sketch and label the graph. So I'm working with p of x. If I just look at p of x, I know that the vertex is 4, 10. And that is the point that they've given us right here. And then 0, -6 is the y-intercept. Well, what's very interesting about the vertex is it's the symmetrical we're going to say symmetrical spot. Not good vocabulary there. But I know that I can draw a line through the vertex, and that is called my line of reflection. So everything on the left side of the line of reflection actually goes to the right side. 1, 2, 3, 4, 1, 2, 3, 4. So there's a very easy second point that I can graph because I know the vertex and I found a point. So I can graph that pretty well. I said pretty well because I'm still hand drawing something. Parabolas are never pointy at the vertex, and my parabola is definitely a little too pointy. All right. So continuing on, it says on the same coordinate plane, identify the vertex and 2 other points that are on the graph of Q. Explain or show your reasoning. So if I look at Q, I have 1/2 x - 4 squared plus 10. Well, P had a negative out front, which means that it's an unhappy parabola. Q is positive out front, so it's a happy parabola. My vertex is still 4, 10, but it is opening up, right? Now, what is my y-intercept? If I evaluate at 0, I get my y-intercept. So this would be 1/2 0 minus 4 squared plus 10. 0 minus 4 is -4. Square that, I get 16. 1/2 of 16 is 8. Plus 10 is 18. So my y-intercept is 0, 18, which is right there. Now we said that vertex is actually a line of reflection. So I can count over 1, 2, 3, 4, 1, 2, 3, 4, and I have the other point. So the y-intercept is not as easy to find, but if I just evaluate my equation at x equals 0, I get my y-intercept pretty easily. And then I can just reflect it over the reflect it over the line of reflection, and that line of reflection occurs at the vertex. All right, so Priya says, once I know the vertex is 4, 10, I can find out without graphing whether the vertex is the maximum or the minimum of function p. I would just compare the coordinates of the vertex to the coordinates of a point on either side of it. That's true. Okay, with the graph that we just finished, the happy parabola, so I plotted the vertex, and then the happy parabola, I found the y-intercept, which is above the vertex. So I knew it was going to open up. With the unhappy parabola, the y-intercept was already graphed for us, but it was below the vertex, so we know it's an unhappy parabola. It opens down. So let's complete the table and then explain how Priya might have reasoned about whether the vertex is maximum or minimum. So here we have the vertex, and if I plug in 3 for p of x, let me see, what was p of x? -3 minus 4 squared plus 10, -1. -1 squared is 1, but that negative is still there. So we have a 9. And then p of 5. 5 minus 4 squared plus 10. 5 minus 4 is 1. So my answer is 9. So because I see that this is my vertex, and that is lower, and that is lower, it is an unhappy parabola, and it opens down. All right, card sort matching. Google Doc. Okay, it'll be in Google Classroom. So go ahead and complete that Google Doc, and I will grade it directly from Classroom. That's it. Good job today.